All right, Mr. Simon here. We're going to just do a real quick review of arrays and array lists before we get started on our array and array list FRQs. Arrays are a collection of things of the same type. So for instance, these square brackets right here mean that we don't just have a single in this array, we have a collection of them. Here we're using a set of curly braces to initialize it. So we're going to have 4 elements in position 0, 1, 2, and 3. The element in position 0 is going to be a 1, and so on. Now that's one way to do it. If we want to do it on separate lines, I could make a new array, and this is where I size the array. So this says the array has 4 positions, but each of those positions are empty. I need to go through one by one and initialize each position. So you can see these 5 lines does the same thing that that line up there does, but sometimes this is useful. Sometimes you want to declare and initialize your array in different parts of the program. When you're making an array of an object type, like string, then you're going to find yourself using the word new twice. We'll use it once here, the yellow new, to set the size. So again, this array is going to have 4 positions. But then we need to fill the array with new strings or new objects. So each element now is going to have a new string at that position. Notice new string square brackets means I'm creating a collection, an array of strings. New string parentheses means I'm actually creating that object called an instance or an example of a string. Now, let's talk about array lists. A lot of people tend to forget the syntax for array lists, and this is where your quick reference guide is going to come in handy. You're going to have one of these out while you're working on the FRQs as well as the actual AP exam. So these are the functions you're expected to know and be able to use in the array list class. They're always going to check to see if you're confused about arrays versus array lists. So this is going to be part of the grading on the array list question. One of the things they look for is, are you correctly using .get with array lists? Are you correctly using square brackets with array lists? Or with arrays. Square brackets only work with arrays, whereas get, set, size, those are the array list functions. There's always going to be a point for not going out of bounds. If you go out of bounds when you loop through an array or an array list, you're going to lose a point. And there's something called I call the array list trap, we're going to see in just a moment. Keep in mind that as far as the AP test is concerned, once you create a new array, that's fixed in size. You can't change the size of an array while the program is running. Array lists, on the other hand, can be added to or removed from, and their size can change. So let's look at the syntax here. Here I'm going to create a new int array of size 3. Then I'm going to fill those 3 elements with 0 in position 0 and 1 in position 1 and 2 in position 2. Notice I start at position 0 and I go up to, but not including, the length of the array. So this is where a less than or equal to would get you a point deduction for going out of bounds. Now, here I'm going to do the same thing with an array list. Notice, though, when I make a new array list, it's empty. So I'm not going to use the list.size right here. I'm going to have to hard code it to run 3 times. And here I'm going to add new elements again, just like I did on the array. 0 in position 0, 1 in position 1, and 2 in position 2. When I use the 1 argument version of add, that adds to the end of the array list. So let's talk about the array list trap. When you're deleting elements from an array list, they shift around. And this can cause problems. If you are trying to delete 2 things that have the same value that are next to each other, it's easy to skip over one. So what do I mean? Well, like, let's say I remove the banana in position 1 in this array list. Well, the coconut that used to be in position 2 is going to move. It's going to, I call it, slide over 1 position, and so now the coconut's in position 1. So let's say I made a loop to go through all the elements in my array list looking for anything that has the word coconut. I want to remove all the coconuts. Well, when I get to position 2, I find a coconut, I remove it, but then the second coconut that used to be in position 3, it moves into position 2. Meanwhile, my loop just keeps on going. So after I remove the coconut in position 2, it then goes to position 3 and finds the durian. It skips the second coconut. Now, there are 3 ways to avoid this trap. One is when you remove from an array list, you can go back to that same position and check it again and see if something moved into that position that you want to remove. A second approach is only go to the next position if you don't remove from the list. And then a third option is to go backwards. If you go backwards, you're moving in the same direction that the elements are shifting, and you're not going to skip over anything. All of those work. Whatever makes the most sense to you is fine. Any way you avoid the trap is fine. So when they're grading this, there's a lot of things they're not going to worry about. If you mess up and write parentheses instead of square brackets or angle brackets, confusing length and size, extra square brackets when you don't need them, an extra number when you're declaring your array, and then misspellings like spelling ArrayList with 1 R, none of that is going to affect your score. When you're going to do one of these FRQs, they're going to give you preconditions and postconditions. The postconditions are the important part. That tells you what your function must do. After it's done, post, these are the conditions that will have been met. Preconditions tell you what you don't have to worry about. So don't waste your time writing code for the preconditions. Preconditions tell you that that's been handled in some other part of the program. So when you're writing your first FRQ here, make sure you're paying attention to the return types. That's always going to be part of the scoring rubric. In num of words length, we're expected to return an int. If we don't return an int, we're going to lose a point. So sometimes it's helpful to look at that return type and then declare a local variable with that same type, and then go down to the bottom of the function and return it. Because a lot of times people forget to write this return. So you want to make sure that's always going to be worth a point. If you have a void as a return type, void means that the function doesn't return anything, so you're not going to be returning anything. Now, you could just write return with a semicolon. That means you're done. You're not returning anything, you're just ending the function, but that's optional. You don't need to do that. So our first FRQ is from the 2004 exam. That was the first year the exam was in Java. It was kind of a softball that year because it was a new language. I think that was the easiest FRQ ever. So we've got this word list, and pay attention here, we've got an array list, and we're going to write a couple of functions that goes through that array list. Now, if you start looking online for answers, and this is where they'll get you on the AP exam, Java's changed a lot since 2004, and you'll see some answers that use very strange looking code that we would not write now. So I have solutions in this presentation that uses the current style of Java. Don't just go off on the internet and start looking for answers, because you're going to find stuff that doesn't make sense anymore. So to best prepare, you're going to want to read the problem. I've put it up on the, there's a link to it on Google Classroom. Take your time to read through the entire FRQ. You're just going to be writing 2 functions, num of words length and remove words of length. And you'll want to write that on a piece of paper, and then to test your solution, you're going to type it into the replit. So if we go over to the replit here, you can see word list, the 2004 FRQ is the second one. You should have already done the linear and binary search assignment. I would do that first before you go to word list. And you'll notice here that in the word list Java file, we have the 2 functions we need to write for parts A and B. We're only writing code in these 2 places. Once you write your code, run it. Check that your output matches the output that is shown in this window here. There's a link to instructions, but they're also in Google Classroom if you want to get them that way. And then if it runs and produces the right output, then just click Submit. That'll run a series of tests. Check to see that you're satisfying both Part A and Part B. And if it works, you're all done. Just click Submit. Again, if it doesn't work, you can click Submit anyway. Now, if you submit anyway, you're saying, I have trouble and can you help me out? You're going to want to send me an email just to make sure that I know I need to look at this and help you out. But click Submit anyway, because if you don't click Submit anyway, I'm not going to be able to see your work. And then send me an email and I'll try and help you with the problem. I've got solutions for the FRQs up on the PowerPoint, but, of course, try to come up with your own solution first. And if you run any trouble and you can't get your solution to work, submit anyway and drop me an email. Good luck. Thanks for watching.